Example number 2 is a definite integral. So our answer is going to be an actual number, a numeric answer. So let's start looking at this. Our first thought might be to do a u substitution, and that is not a bad thought. If we were to do a u substitution, we would want u to be that part under the square root. That's the function within a function. So 4 minus x squared. So that would make du negative 2x dx. And we would want to divide both sides by negative 2. So we would get this. That's a negative right there. So that would almost work, because if we made this that u substitution, we do have an x dx. The problem is that plus 3. That's kind of in the way. So what we'll do, we can deal with this, is we're going to split this up, kind of like we did the last problem. So we're going to split it up. Instead of x plus 3, we'll put x over that thing plus, and then we'll do 3 over that thing. So you're allowed to split up the numerator like that, no problem. And then you'll see this u substitution is going to work great in that first part. So let's go ahead and do that. Oh, and this is from 0 to 1. I didn't write that in. I'll put it in the next step. Okay, so we have u in our denominator, and then this x dx gets replaced with du over negative 2. I'm going to go ahead and pull out that negative 1/2. And this is from 0 to 1. So negative 1/2. Now, these, I'm going to do those in blue. Those are still x values. I did not change those to u's. I definitely could. I just don't think I'm going to right now. Okay, so this is u to the negative 1/2. And I'm still going to write those in blue because those are x values, not u values. I need to remember to switch them back. Okay, so we have negative 1/2. Antiderivative is going to be u to the positive 1/2. We balance that with a 2. Yep, that looks right. And then we are going to plug in 1 and 0, but remember those are x values, so I'm not going to do it yet. All right, so we get negative u to the 1/2, which is the square root of u. And remember, u was 4 minus x squared. And we're evaluating that from 1 to 0. Okay, we'll come over here to finish this problem out. So we get negative, we're going to plug in 1. So negative square root of 3 minus negative square root of 4. So negative root 3 plus 2. That was just for the first half of the problem. Okay, we still got to tackle the other half. I am just checking my notes to make sure I have the right answer for that, and I do. Yay. Okay. All right. So now remember, we left this other thing hanging out over here. We now need to finish the problem. A u substitution is not going to work here because remember, in the u substitution, we had the x dx. We don't have an x in the numerator. So let's see. I'm going to pull that 3 out. That's just a constant. And then I have this 1 over square root. Oh, I think I see this. This is 2 squared minus x squared. And you'll want to go back and look at the arctangent, arcsecant, arcsine. But I believe this one is an arcsine, if I remember correctly. Yep, it's an arcsine. Okay, so arcsine is going to be, that's just our constant there. Arcsine is u over a, so our u is x, and our a is 2. Okay. And we are evaluating from 1 to 0. So we have three arcsine of 1/2 minus 3 arcsine of 0. So to evaluate this, remember we are looking for where sine is 1/2. Okay, so we'll draw that. So let's put it here, I guess. It's going to be, and we're in the first quadrant. So we have opposite, hypotenuse. So that's a 30-degree angle. 30-degree angle is pi over 6. And then arcsine of 0, we're thinking about where is the sine 0, and that's going to happen right here at 0. So this is minus 3 times 0. And so we get, for this part, we get plus 3 pi over 6 minus 0, so plus pi over 2. So this is our exact value answer, or if you wanted to put it in your calculator, 1.839. Okay. All right. We got time on this video. Yeah, let's do this. Let's do this last one. All right, number 3. Let's see what kind of trouble we can get in here. Well, we might think about a u substitution. That's a lot of times what we start with. If we were to do a u substitution, we would probably make u 16 minus x to the 6, which would make du negative 6x to the 5th, and we would divide both sides by negative 6. Now, I do not have an x to the 5th in the problem. All I have is an x squared. So u substitution is not going to work. It was a nice idea, but not going to work. All right. You may have looked at this and said, hey, that looks kind of like the last problem, with the arcsine. And you would be right. It does kind of look like that, sort of. So remember, arcsine is when you have a constant squared, which we do, minus some variable squared. Well, we have x to the 6, which is the same thing as x cubed squared. Now let's try and do a u substitution, a different u substitution. Let's let u be x cubed, which is going to make du 3x squared, like that. So now when we plug that in, we get, I didn't do anything with this. This is 4 squared. And then this is my u value. So I have 4 squared minus u squared. And then up here on top, x squared dx. Oh, I forgot the dx over here. X squared dx, that's my du over 3. So du, I'm going to pull that 1/3 out right away. And now you can see I do have an arcsine here, okay? So we have 1/3. This is going to be arcsine of u over a. And then for my last step, I need to plug back in, substitute back for u. So we get arcsine of x cubed over 4.